The world's major navies spend a lot of time and effort developing submarine hunting technology. Then the hydrographers discover that you can use this to chart the bottom of the sea.
Scientists say we've explored less than 5% of the ocean floor. What they don't say is that some of the places we have explored don't behave like the rest of the planet. At 11,034 meters, instruments come back damaged, data goes missing, and events get quietly labeled unclassified. It's not because the equipment failed. It's because what was recorded down there doesn't fit the rules science depends on. And admitting that would be far more disturbing than anything living in the dark. To understand why the data from 11,034 meters is so unsettling, you first have to understand what that environment is supposed to do to everything that enters it. Pressure increases by 1 atmosphere every 10 meters. By the time you reach the Hadal Zone, that pressure is no longer just crushing, it's structurally dominant. At the bottom of the Challenger Deep, water presses inward with more force than 50 fully loaded jumbo jets stacked on a single square inch. There is no margin, no tolerance. Anything fragile is erased instantly. The temperature down there stays between 34 and 39 degrees Fahrenheit, cold enough to slow chemical reactions to a crawl, cold enough to lock motion into sluggish predictability. And there is no light, not dim light, zero light. The sun's energy disappears thousands of meters above this point. Physics tells us what should happen here. Movement should be minimal, energy should be scarce, change should be slow. Life, if it exists at all, should cling to survival at the edge of chemical possibility. That's why the Hadal Zone was once thought to be a biological dead end, a place where complexity breaks down, where only the simplest forms of existence could persist, if any. And yet, when sensors are placed on the seafloor at these depths, the readings don't reflect a frozen, inert world. They show variation, sudden spikes in pressure, temperature changes that occur too fast for deep ocean currents, acoustic signals that appear and vanish without warning. Each of these readings on its own could be dismissed. Together, they suggest something far more troubling. Because if an environment this extreme is producing dynamic events, then the assumptions we've made about the limits of energy, motion, and stability at the deepest part of the ocean may already be wrong. And that realization is where the unease truly begins. Before the deep ocean became a place of unsettling questions, it was a place of careful proof. In 1960, the bathyscaphe Trieste carried Don Walsh and Jacques Piccard to the bottom of the Challenger Deep. For nearly 5 hours, they sat inside a steel sphere as the pressure outside climbed past anything humans had ever experienced. When they reached the seafloor, they didn't find emptiness. They reported seeing a flat fish-like organism, alive and moving. That single observation shattered the belief that complex life could not survive at such depths. Decades later, unmanned probes pushed the evidence further. In 1995, the Japanese remotely operated vehicle Kaiko returned samples from nearly the same depth. Inside them were foraminifera, single-celled organisms thriving under pressures once thought lethal. Some were later found to grow to sizes measured in inches, a phenomenon known as deep-sea giantism. Then came the most precise discoveries. Scientists identified snailfish living deeper than any known other fish, right at the theoretical pressure limit for bony animals. Their survival depends on a chemical called TMAO, which stabilizes proteins under crushing pressure. Calculations showed there was a hard limit. Below a certain depth, even this adaptation should fail. And yet, life didn't stop neatly at that boundary. Even more unsettling were xenophyophores, giant single-celled organisms sometimes larger than a human hand, No skeleton, no muscles, just a fragile biological structure existing where physics says it shouldn't. These discoveries were celebrated publicly. They proved life could adapt in astonishing ways. But quietly, they raised a more dangerous question. If biology is already operating at the very edge of what physics allows, what happens when the data suggests something is operating beyond that edge? For a long time, the deepest discoveries were framed as a victory for biology, proof that life, however fragile, could endure almost anything. But buried in the mission logs was a quiet shift in tone. Because the most unsettling findings from the Hadal Zone were not biological. They didn't come from cameras focused on the mud or nets collecting microorganisms. They came from instruments designed to listen. Hydrophones placed near deep trenches began detecting ultra-low frequency sounds that did not behave like earthquakes, currents, or known marine animals. Some were described in internal notes as scrapes and shudders, terms rarely used in oceanography. At the same time, landers reported energy spikes, sudden electrical noise strong enough to overload sensors rated for extreme conditions. In a place where energy should be scarce and stable, these bursts appeared without warning and vanished just as quickly. Then there were the sonar returns. On a handful of dives, short-range sonar detected fast-moving echo-dense objects passing beneath or beside unmanned vehicles. Too solid to be turbulence, too large to be debris, and moving at speeds that contradict everything known about life at those depths. Official explanations were brief: thermal layering, instrument error, acoustic interference. But here's the catch. The Hadal Zone is one of the most thermally stable environments on Earth. Temperature layers don't shift suddenly at 36,000 feet. Currents don't accelerate without energy input, and equipment failures don't repeat in the same way across unrelated missions. What the data hinted at was motion, force, and activity in a place that should be nearly motionless. And that is where the story stopped being about what lives down there and started becoming about what moves. When something strange happens in science, the usual response is discussion. Papers are written, arguments happen in public, competing teams try to explain the same data in different ways. That is not what happened here. Across multiple deep-sea missions, the same pattern appears. Raw data is collected, anomalies are noted, then in the public-facing reports, those details quietly disappear. What remains are clean summaries focused on sediment samples, water chemistry, and known organisms. In the internal records, however, the language changes. Phrases like unclassified acoustic event appear without follow-up. Sudden pressure shifts are marked as sensor drift, even when backup instruments record the same spike. Short sections of data are labeled corrupted or unrecoverable, with no technical explanation attached. This isn't secrecy in the dramatic sense. There are no warnings or alarms, just omission. Researchers involved in these dives are briefed on what they can discuss publicly. The reasoning is practical. Data that cannot be explained cannot be verified, and data that cannot be verified risks undermining decades of carefully built models about how the deep ocean behaves. Admitting uncertainty at this level isn't harmless. It would mean acknowledging that core assumptions about pressure, energy, and stability at extreme depths may be incomplete. So the silence becomes procedural. Not because scientists are hiding monsters, but because admitting they don't fully understand the deepest environment on Earth would raise a question with no safe answer. If these readings are real, and they repeat, what else is happening down there that no one is prepared to explain? The ocean floor at these depths doesn't rely on stories. It speaks through metal, mud, and broken equipment. And that is where the most undeniable evidence emerges.
Unmanned landers, designed to survive over 16,000 pounds per square inch of pressure, have returned from dives with damage that defies explanation. Titanium hulls scored and gouged as if scraped by something massive and curved. Not jagged rocks, not sediment, because the trenches are covered in soft, undisturbed mud. The damage is localized, precise, and consistent with a force far beyond any known animal. Then there are the tracks. Sonar images and limited footage show linear furrows cutting through the ocean floor, sometimes over 3 feet wide, stretching for hundreds of feet. They start abruptly and end abruptly, as if a colossal object settled, moved, and lifted itself from the mud. No chain, no anchor, no known organism could create these impressions. Even the giant amphipods, the largest deep-sea crustaceans, are too small. Even the xenophyophores are too fragile, and items have vanished. On one expedition to the Japan Trench, a set of biodegradable bait cages disappeared entirely. Only a smooth circular depression remained. Metal, wiring, and equipment all gone. The log entry reads simply, "Unrecoverable object." This is what makes the data unnerving. The Hadal Zone communicates through physical interaction, not spectacle. Damage and displacement, sudden motion in the mud, the disappearance of instruments, all of it points toward an unknown presence or force, something with immense size and strength, capable of moving through a world where even titanium struggles to hold its shape. And yet all this is buried in quiet clinical reports, dismissed as anomalies. The ocean floor is sending warnings, but they are written in scratch marks and missing metal, not words. The ocean floor at these depths is not simply a passive stage for strange creatures. It is a pressure cooker of geologic energy. The Hadal Zone sits atop subduction zones, where tectonic plates grind against each other with unimaginable force. The stress is constant, silent, and waiting. Hydrothermal vents release superheated water at temperatures exceeding 850 degrees Fahrenheit, held in check only by the crushing pressure of the water above. In the Mariana Trench
itself, near the Challenger Deep, there are underwater volcanoes and molten sulfur pools. Daikoku Seamount alone contains lakes of molten sulfur, bubbling at over 370 degrees Fahrenheit, mixing instantly with near-freezing ocean water. Any submersible approaching too closely risks corrosion, structural failure, or worse. Seismic monitors record hundreds of minor tremors, too small for the world to notice, yet indications of immense pressure building silently beneath the seafloor. Some formations, like the superdense structures beneath the Puerto Rican Trench, exert localized gravitational anomalies, slightly warping the ocean surface above them. These aren't theoretical, they are measured, consistent, and unexplained in the public domain. And then there are the sudden bursts. Temperature spikes recorded over mere seconds, energy bursts strong enough to stress sensors, all in places officially considered stable. These micro-events hint at forces that could, if unleashed fully, rearrange the ocean floor violently, generating seismic shocks that dwarf known earthquakes. The Hadal Zone is a thin lid holding back a colossal, simmering furnace of geological energy. It is a world where pressure, heat, and gravity collide in ways that defy surface intuition. And each recorded anomaly suggests that the next event could be far larger, far more destructive, and far more inexplicable than anything already documented. Even after decades of exploration, the deepest zones of the ocean remain a half-mapped frontier. Instruments record anomalies, landers return damaged, tracks appear where no creature could leave them. Temperature and pressure shift in ways that defy established physics. And yet, the official record remains cautious, clinical, silent.
We are left with a paradox, a world where life pushes the limits of biology, where geological forces simmer beneath a thin, crushing lid, and where physical evidence hints at unknown presences capable of moving, scraping, and disappearing in ways science cannot yet explain. Scientists speak of microbursts, sonar artifacts, and instrument errors, but their internal logs whisper a different story. There are events that do not fit the models, phenomena that remain classified, unreported, or deliberately understated. A single metallic snap, a sudden temperature spike, a missing instrument, each is a hint of a reality larger and more active than we are prepared to acknowledge. The Hadal Zone does not reveal itself slowly. It presents contradictions, life at impossible pressures, energy in places thought inert, movement in the stillest mud. Every anomaly accumulates, layering tension across the ocean floor, building a silent, inescapable dread. And as the landers ascend, carrying their damaged hulls and incomplete data, one truth becomes clear. The Hadal Zone is not merely a bottomless pit. It is a hidden, active world, operating under rules we barely understand. And whatever's moving, scraping, or surging through that darkness is still down there, waiting, watching. The question is not whether we will explore it further. The question is, will we survive the next revelation it chooses to make?